So there are two ways that you can compare radicals in order to arrange them from least to greatest. One way is if it happens to be on a non-calculator part of a quiz or a test. How do you do that without your calculator? How do you compare 5 root 2's and 2 root 5's? Which number is bigger? And the other way, of course, is if you have your calculator. Well, if you have your calculator, you type them into your calculator, and you can tell from the decimals which one's bigger and which one's smaller. So more importantly right now is how do we do things non-calculator? And the key to that is writing them as entire radicals. So for our first one, we have 5 root 2, 2 root 5, and 4 root 3. Since they're all different square roots, we have a root 2, a root 5, and a root 3, we're going to write each of these as entire radicals. Now, you might have remembered from our family of root 2 what this is equal to. You might also remember that you can change 5 root 2 by saying 5 is equal to the square root of 25. And if I have the square root of 25 times the square root of 2, I get the square root of 50. I can't multiply 5 times 2 like this, but if I have them both as square roots, then I am allowed to multiply them together. So root 25 times root 2 is root 50. So what we did here is we changed this 5, because 5 times root 2 is the same as square root of 25 times root 2. And then once you have a square root times a square root, you are allowed to multiply inside. If I have 2 root 5's, I'm going to change my 2 to the square root of 4. And that's going to make square root of 20. And you can already see that square root of 50 will be bigger than the square root of 20. And finally, 4 root 3, well, that's the same as square root of 16 times the square root of 3, which is the square root of 48. So if we are arranging these from greatest to least, root 50 is the greatest, then root 48, and the least one is root 20. Or if you wanted to write them as their mixed radicals, we would start with 5 root 2, then 4 root 3, and finally 2 root 5. And that would order them from greatest to least. So this one you could do with a non-calculator. B you can do with non-calculator as well, and you can even skip the step of changing them to entire radicals, because we have 9 cube roots of 2, 11 cube roots of 2, and 8 cube roots of 2. Which one do you think is the biggest? 11, because they're already in the same radicals. In fact, they're already like terms. So 11 is the biggest. So 11 cube roots of 2 is the biggest, followed by 9 cube roots of 2 is second biggest, and the least one would be 8 cube roots of 2. So if they're already all part of the same family, it's easy to tell which one's the biggest and which one's the smallest. For the last one, since we're dealing with different kinds, we have fourth roots, square roots, and cube roots, part C would only show up if it was on a calculator part. So you would go to your calculator. So I get the first 2 rows to figure out what 3 times the fourth root of 8 is. The next 2 rows to figure out what 4 square root of 2 is. And the last 3 rows to figure out what 3 cube root of 5 is. as a decimal. Someone from the first two rows, do you have 3 times the 4th root of 8? No, I just want a decimal. Just type it into your calculator. 5.045. And it goes on from that. Someone from the second two rows, do you have 4 root 2? 5.66 for this one. And 3 cube root of 5. Does someone have 3 cube root of 5? 5.13. So obviously this is the biggest one, this one is the least, and you could order them that way. So when you're doing your questions for practice, number 5, do without your calculator, and number 9, you can use your calculator.